Good morning, good afternoon, Matrix. Like I promised to make this video for you. So let's get right into it. What is the purpose of the video? Well, the purpose of the video is for us to cover analytical geometry. But this is specific to Matric. And when I say Matric, the grade 11 analytical geometry that you did was focusing on points, lines, inclination, and all these type of things that you need to go home and actually revise it yourself. But this analytical geometry focuses on circle geometry. So instead, we have circles now. And just like we've been doing with lines, we need to find the equation of the circle. So that's the first segment of the video, is that we're going to be finding the equation of the circle. Right? And the second segment of the video, we'll be looking at how do we, from the equation of the circle, how do we find parameters like the center? How do we know what are the coordinates of the center just from the equation? And how do we know the radius? How do we find the radius from the equation, right? And then video number 3, I'll try and divide these videos per concept. Video number 3 will be on, now that we have the equation, now that we've seen how do we calculate the center and the radius, now we're going to look at how do we get the equation of tangents to the circle. So we're going to look at tangents to a circle, and finally, video number 4 will look at the relationship between two circles. So if I have two circles, how far are they from each other? Are they touching? How many times are they touching? And so on and so on and so on. So this is the relationship between two circles. So that's really what grade 12 analytical geometry is all about. It's all about, can you find the equation of the circle? If I give you the picture, can you extract from the picture the important paramount information that will help you find the equation? Number 2 is that now, given the equation, can you walk around the equation? Use your skills that you learned in grade 11, skills like completing a square, so that it looks in standard form, so that we can extract these. What is the center and what is the radius of the circle? And number 3, we're going to look at tangents to a circle. Remember when you guys did Euclidean geometry? If you get a circle, a tangent is just a line that touches the circle only at one point. And it makes a right angle with the radius, right? It makes a 90-degree with the radius. So we're going to look at that. And lastly, we're going to look at two relationships, the relationship between two circles. So the videos are going to be divided in that segment. And this video will start with the equation of a circle. Let me just find something to wipe. So I'll go through 1 or 2 examples, and then I'll leave you with the exercise, and you can go home and practice these things, right? Obviously, after looking at the examples that I've done with you. So let's start with the standard form that these equations could come, right? Just like how you get a parabola, and a parabola looks like a y is equal to ax plus the p squared plus the q. That's an equation of a parabola. We all agree, right? Now that is the general formula of a parabola. It's called the general formula. And as soon as you get into specific parabolas, you're going to have to find the A, the P, and the Q, right? So now let's look at the general formula of a circle. So circles, the ones that have the center at the origin, have this general formula here. X squared plus y squared is equal to r squared. So what does this mean? That the center is at the origin. Well, if you think about a Cartesian plane, that point right there where x and y are 0 is called the origin. So what do I mean if I'm talking about a circle that has its center at the origin? It just means that the circle goes around that point, and that's your center. So we'll call that guy C. Do you understand? So that's how your circle looks. And that's the general formula of that type of circle, right? Just like I alluded to the formula of a parabola, the x and the y in that formula are just coordinates on the parabola. Remember? Similarly, the x and the y here represent just a point on the circle there. So if I have the x and the y of A, then I could just substitute there and find the radius, right? And if I have the x and y of B, I could just substitute in there and find the radius. It's going to be the same as if I use the points of A. Do you get what I mean? And so let's actually use this as an example. Let's say the coordinates of A there were 1 and 2, right? How would the equation of the circle, of this specific circle, look like? So how do you calculate that? All you need to do is substitute the 1 for x, substitute the 2 for y, and what are you trying to find? You're trying to find that r squared value. That's what we're trying to do here. So if you square the 1, you get 1. If you square the 2, you get 4. And so r squared is just 5. So now we found our r squared value. Guys, you don't need to square root this value. It's only if you asked for the radius. If you ask for the radius, then by all means square root that value. But if you just asked for the equation, you don't need to square root that value, because therefore your equation is x squared plus y squared is equal to that same very r squared value, which is 5. So that is the equation of this circle. Got it? So now let's move on. How do we find equations of other circles that are not at the origin, where the center is not at the origin? First of all, how does the general formula look? How does the general formula look? Right? So these are circles not at, or rather let me say center not at origin, because we already know we're speaking about circles, but I'm speaking specifically about the center of that circle. So center not at origin. How does the formula look? You have an x minus the x of the center. So that's the same coordinate x we were speaking about in the previous question, right? That's any x coordinate that is on your circle. But this x coordinate speaks about the coordinate of the center, the x coordinate of the center. So moving right along. And then you add this, it has y minus y of center squared is equal to r squared. So that's how the general formula looks. Looks similar to the first one. It's just that now there's these C coordinates that we're looking for, and C means center in this case, right? So let me give you an example. Let's say we got that as the circle, right? And the coordinates of C, the center there, are given as 2 and 1, right? And we asked to find the coordinates of, or well, to find the equation of the circle. So one thing you're gonna need is that you're gonna need one of these two things. You're gonna either need them to give you another point there, let's say an A value there, or just gonna guess values 4 and 5, or rather 5 and 4, the other way around. So you're gonna either need another coordinate on the circumference, or you're gonna need the radius of that guy. So let's work with it if you're given just the coordinate of a point on the circumference. So how do you work with it? You start off with your formula and you substitute the coordinates of C. But now look at our equation. It has a minus in there. That means if I'm going to substitute that coordinate of C, which is a 2 and a 1, then here it's going to become a minus 2 squared, obviously, plus, if I'm going to substitute that coordinate of C, which is 1, the y coordinate of C, I'm going to have a minus 1 in there. And then this is all equal to r squared. Got it? So there, the only coordinates you ever substitute there is only the center coordinates. I hope you guys are getting that. The only thing that could ever go in there is the coordinates of the center. All right, so now we have this. What else can we do there? Like I said, for you to find the equation, you need one more point, and we're given one more point, that A value. So what we're going to do is we're going to substitute the 5 for the x here. We're going to substitute the 4 for the y there. And we're going to try and solve for the equation. So 5 minus 2 gives you a 3. If you square the 3, you get a 9. That minus that gives you a 3 as well. If you square that 3, you get a 9. And so my r squared value is actually 18. 9 plus 9, which is 18, right? So now I got my r squared value. Therefore, the equation of this guy is x. I need to substitute my c value there. The y minus the 1, all equal to, what is the r squared value that I just found? It's 18. So that is how you find the equation, right? But that's just one way. You could find it another way. Just erase this, take the same circle, but now I want to make it a little bit bigger. So right, we're doing a second example, and now I want to show you how else you can find this. Is that instead, what if they give you the distance there and they give you that it's 4 units? So what they're actually giving you is that r value, not the r squared value, but the r value, the radius. And so all you need to do is, for us to find r squared, we just need to take that and we square it. We get 16, right? We have our r squared value. All we need to do there is substitute the center coordinates, of which we do have the center. And so therefore our equation is x minus the 2 squared plus y minus the 1 squared, all equal to 16. And that is our equation. Do you get it, matrix? So, point of this video is to show you that first of all, you get two different kinds of circles. Circles that have the center at the origin, the formula looks different. And you get another type of circle, these ones here, where the center is not at the origin, and so you need to be given those coordinates of the center to actually find the equation of the circle, right? Now let's look at another example, just one more example on these. Give me a second. All right, matrix, going back to this example. Let's say you're given this type of circle. If you can see this clearly, that's 8 right there on the y-axis, and you're given -4 down there on your x-axis. And you obviously asked to find the equation of this circle here. So I want you to pause the video and think for a bit, what would you do in order to help you find this equation? And then once you've processed at least that part of the of answering the question, then you can replay the video and check it out. So what I'm going to do is that I'm going to use my knowledge of circles and tangents. I know for a fact that that guy touches my circle only once, right? And right there where it touches is the same point that I'm given there, the -4. So what I can tell is that if I draw a perpendicular line going from there, one that makes a 90 degrees, then this will certainly pass through my center. Right? That's what tangents and radiuses do. They make a 90-degree angle. Right? So if that passes through my center, another thing that I know is that if that passes through my center, then the coordinate, the x-coordinate of my center, has to be that -4. Right? So I'm not saying that radius is -4. I'm saying the center, the coordinates of the center has to be that same -4, because if I just go up like that and it's perpendicular, that means all those coordinates going up like that are all -4, the x-coordinate of it, right? So I got that in the bag, and now I think to myself, what would be this distance here? That distance going from there to there will be r, right? That's radius. And so actually the other y coordinate of that c value is r, which is my radius. And so now that I've established that, I've established the center in terms of r, which is -4 and r. And I have another point there, which is what? I'll call it A, which is 0 and 8. And now that I have the center and another coordinate, I can definitely solve for my equation. This is going to be obviously longer, but there is your general formula. Right, and from the general formula, I substitute my coordinates of my center first. So it looks like x minus or plus the 4. Because it's a -4, once you put it inside the coordinate there, it becomes a +4. Once you substitute it inside your formula, it becomes a +4. So you square it like that, plus the y, and that's a minus r, and you're squaring it like that, and this is all equal to r squared. Right? So at least I've done one part. I've substituted the center coordinates. And now I need to substitute that other coordinate that is on the circumference. When I substitute that, 0 goes in for x. For the y, it's 8. And all of this gives me an r squared value. And now I have the duty to solve this equation. But I have an r there, and I have an r squared that side. So it's going to come out as if like it's a quadratic. But let's see. So 0 plus 4, and if I square that value, I get a 16. Here I'm doing, it's a square on a binomial, so I have to rewrite that bracket twice. And that's what I get. Then if I simplify that guy, I get a 64 minus 8r minus 8r plus r squared is all equal to r squared. So what I'm noticing is that r squared there and the r squared that side are going to cancel. If I take one to the other side, it's going to subtract with the other one. So that is already cancelling. And these 8r's are going to add and give me 16r. Right? A negative 16r. And the 16 plus the 64, what do those give me? Don't those just give me 80? They should give me 80, and I take that 80 to the other side, I have a negative 80, and so if I divide by negative 16 on both sides, I'll get that my R value is actually equal to, let me just check, 5. So if my R value is 5, can I find my equation? I hope you guys are screaming yes, yes, yes. So how do I find my equation? X minus the center coordinates, of which was a minus and now becomes a plus. Y, find my R, so I can substitute it there for the center coordinates, which is a 5. So this is a minus 5 squared, all equal to r squared is 25. So that is my equation back there. Do you see it, guys? So that's how you work through these type of examples. They might give you more of these in your exam because these need a little bit of thinking. But as soon as you know that a tangent and a radius make a 90-degree angle, you can already find one of those one of those center coordinates, right? Then once you find one of them, then the other one you can conclude from whatever you just determined there that it has to be r. If it goes down, then it's a minus r. Do you get what I mean? And then you can substitute it and solve for it. So that's the end of this video. And that's everything to know about how do you find an equation, how does the equation look for different type of circles, and yeah, the r squared value, and the r, the radius, and the radius squared. So understanding those important concepts is very important. So thank you guys. Check out the next video.